this is
channel 1.
red. Is it positive coming right?
Yeah.
So this is red, red. This is the black one.
Oh.
Right, so this one goes to your channel 1 on the oscilloscope. Using a coaxial cable. You know which one? This one now. This one? No, this one. This one coaxial. Coaxial, this one, yeah. Okay, coaxial. This one, red, black, huh? Okay, this is to connect to here, one channel. We got channel 1. Channel 2 is this one. Now, channel 2 here, you have to be a little bit careful because channel 2, if you use channel 2 as red, black, though is correct because this is coming right, red and black. But these two, when you go to the oscilloscope, you realize that it is coaxial, that means you plug in all connected. This one is your red, channel 1, this channel 2. This one also red. These two okay, but these two here internally already common the red. This is the black. This one already internally common inside, hidden. So you can see that they short out, right? You connect like that, this point, this black, go here, short. So this is short out, so you got problem, right? So this one, you can use one. The other one, what you can do is do this way. Okay, this one, you use the third channel. Third channel also need to, okay. So these two you need to separate, right? Can you remember what you used to do that? Can you still recall, no? Your experiment of 2, where you use the thyristor. The other probe is called differential voltage probe, right? Remember? Differential voltage probe? No. So this one, use differential voltage probe. Differential voltage probe. So this one comes to here, still red, this still red, black. Come here, red, black. This one times, you step down, okay? So this one normally you will reduce it to
the big one, black one.
what's
The black one.
what's the smallest? Times 100, times 100. Remember, 100 volt goes in, this one reduced to 1 volt. This one is times 1, in direct is times 1. So this one on the probe, on the second channel, you must set to probe setting times 100. Okay? Now what you put this one? Now you put this one has got the internal. This one got the internal circuitry. This one requires supply power. You have an adapter to pump power. This one don't need, right? So this internal adapter will actually provide power for this circuitry to reduce the voltage to the correct scalable level. At the same time, we will separate the common here. This and this actually the floating, right? So therefore, this one will go short to here. Otherwise, direct then this will through the scope, the short. Okay. So you got to use a differential probe for this one, alright? Hello, are you for it? If you're not sure, then after you put your hand if you are not sure, we check for you. Okay, so you got 2 channels right over here. Then the next thing is you need to look at the setting. This one, the on off of this, how fast the frequency, how fast? How fast on off? Control like that fast, not very.
You like
This on off very fast. So this one, how fast we control by this. This box here has got some electronic circuit. Alright, the electronic circuit is the oscillator, which can adjust the duty cycle, the frequency. So this top here controls how fast you turn on and off. So, but it's not calibrated, problem. Not calibrated. So you have to depend on the oscilloscope to check how fast it's turning. Alright, so how to check? Actually, you can check these two if you know the waveform. But if you're still not familiar, then the best way to check switch is because the switch is the direct one, right? On off. So to check whether it's on or off, you can check right on and off. By now, after the first chapter, is to know by looking at the waveform, is it on or off, right? High or low, high or low, high or low, right? So you need to connect one more channel, this one. Now this channel, not compulsory, I never put down on this one. Channel 1 and 2 only, right? Last time it's 2 channels. So now you have 3 channels, so I think it's good to look at it. Alright, check this one. So this one you can put direct to this one. So this one I use differential already, like that, This one you use the differential probe because this black and this black go to channel 3, channel 3. This red. So this channel 3 again goes here, and this black goes here. This black is also shorted here. The black is not shorted for the channel. So you must separate it, so you must have differential voltage probe. Again, times 100 Okay? Times 100. Do the same thing. So you have separate the two big probe. Okay? Are you following? Alright, So now you look at this one, the waveform. You can tell which one on, right? Because this one shows you, let's say channel 3. Channel 3 will be, this voltage is what? VSW, the voltage across the switch. VSW, 0 volt, open or close, 0 volt, then the other one is 24.
So 24 low power loss.
Okay, you want to be accurate? 23 point something, 24 almost. Okay, close enough. Okay, so this one on. Which one on? Can tell me anyone? These are usual questions.
Switch on.
T off. T off. 2 choices, 1 or 2. Two. So 1 or 2?
2.
Anyone say 1?
No.
Good. Alright, I think you are solid. Few study, the rest also.
Switch on.
This one is 0 volt. Then this is closed voltage, don't have. Or 0.7.
Yeah.
So this one should be right, on. So this one, 2, not 1, 1 then salah,
Learn from mistake.
So the lab is also a chance to learn because the lab one will learn better because you see the actual thing. Okay? So this one off, on. Okay? So now you can adjust it. Alright, adjust to get the correct frequency. So what frequency you want? They say that the frequency you want to use is to set. Right? Connect everything, then check for connection. Right? Then power out, do not power out, still check for you. Then I think about 6 stations, 5 stations. 6 stations. Okay, good. In that case, I think tonight you can have 2 to 1 station for most, except for 2. 2 stations with 3. 2 station, 3 person. So I think you can have chance to work on it because not so many people. So the best is one connect, one check, then change over the time. The other one will check whether connect, the one will connect, will checking. So you have a chance to practice each one. Because during the lab test, you'll be on your own. Right? So you better learn. Then don't be a recording secretary. Okay, I finished. I haven't finished yet. I don't go. I finished. So here, power the equipment are going to be checked. Then set the frequency to 2 kilohertz, right? So now to set that's how I told you put the VSW on the channel 3, then you turn the knob there, right? Frequency control. So you can check, right, the frequency. Hello, you can remember to check frequency. Signal go in, how to check the frequency? Can you don't know, then you talk to your partner. Cannot, then call me again. Right? Call Mr. Lee again. Yeah? Okay. Alright, after set to 2 kHz, then we adjust the control knob, label duty cycle until the K, the duty cycle is 30%. 0.3 is 30%. Huh? Okay? 100% is 1. Alright? 0% is 0. Okay, I'll change this one to 0.3. First setting, 0.3. In fact, we need to fill in the table. We need to fill in the table, the experiment. 0.3, then we know the period is what? The period is 2 kHz, right? So 1 over 2 kHz will give you 0.5. So this is period. Then we want you to observe the waveform and record the VDC, T dot, T on, delta V peak to peak in the table 1. So this one, no problem, use the voltmeter. Okay, we go ahead. Okay, here. Right, so this is the voltmeter, right? So this side is the VDC, okay? Alright. You try and put here. Okay, say because the ripple is blocked out by this smoothen. The DC average value is this one, same as here. Oh, you can try your cleaner. Imagine here also not wrong, huh? So it's the R, this one is L, huh? This is the switch. Okay, so this one, this is a voltmeter, record put here, DMN. T on you already know, right? Because 0.3, right? Right? How do you get 0.3? Here, how to tell? Oh, okay. So now we go back to there. This one a little bit more elaborate because this one doesn't show the duty cycle, right? This one change the frequency, we know that. When I change the frequency to 2 kHz, this one will be 0.5 millisecond, right? 1 over F. Alright? Okay, this one you know. This one change the duty cycle. We change this one. You want 30% duty cycle means T on here is how many? T on is equals to KT. Can you still remember? K is equals to T on over T, right? So this bring over. Okay? Okay? So now K is 0.3, T is
0.5.
yes. So it's 0.15 millisecond. So can you set to 30%? Very simple. Looking at this waveform here, you adjust this. Now don't touch this, huh? This one you set to 2 kHz, leave it there. Then you adjust. This is a duty cycle. So adjust this one fixed, this one will move. Oh, this will move. Okay? You move up there, this is how much?
0.7.
Yes, 0.15 millisecond. Alright? Let's stop there. That is the setting we want for the first reading. Alright? Are you following? Okay, so now after that you take the reading. This one will be VLDC. Then what else do you need to measure? The table says you can measure peak to peak, delta V peak to peak. Remember I told you the waveform here is not straight, huh? This is straight. But this not, this one is right? Agree? 0 volts. This one is ripple. So this one is the delta V peak to peak. This one. Okay? So you can only use the oscilloscope to observe channel 1, right? Is it channel 1? That's all? Channel 1, channel 2, channel 3, right?
Yeah.
Channel 1, look at it, then you measure. How much is this? I hope you can still remember. Use cursor. Use cursor. If you can't remember, then talk to your teammate. You can't remember the cost. Alright? Because they are fixed group. So if everyone start at the same time, you can't service everybody. Take turns. So you know then, don't listen. You can carry on. Which is good. because you have 3X, right? 3X or 2X per station. Very powerful, no? More powerful than computer, huh? How come you all what? You all no sense of humor, correct? You're more powerful than computer, 2X together. Okay, done. How about this one? Delta V RMS. This ripple component has got it's a AC, right? It's a ripple. So what is the RMS value? So actually you can use a scope to filter out the DC component, measure the RMS value. Otherwise you can use this, because not everyone have a transient scope, huh? For that, no problem you have. So you can do this formula. The delta ripple RMS is equal to a peak to peak. This one you already measure, right? Over here. Divided by 2 square root 3. Okay, answer. Okay? Can I? Okay. This one compute. This one take this measure. This one don't compute. Oh. This one is the quality of the DC, TAC. So it's the ripple AC component as a fraction of the DC. Where's the DC? DC is this one, right? Actually it's here. VDC. Remember I told you the average? Huh? So this VDC is measured by this. So this already have. This already have. So this one divided by this give you the quality. Alright? Total harmonic distortion, okay? Can?
That is compute one or need to read the reading?
This one?
The last row.
This one compute, this one compute one.
Yeah, no. I mean the
This one, sorry, this measure. One compute, one measure. So,
So the last row will be compute.
take this measure. Take measure. This one did adjust and compute the value. This one compute from here. Alright? Compute from this one, be pick to pick. Got this formula, right? And then this one is this divided by this.
Okay, so
Okay.
compute for compute.
Right? So this one compute here. Okay, let's finish one reading. You need to do 5 readings, 30% up to 70%. Do the same thing. So 0.4, you want to repeat again? Can I?
No need.
No need.
Okay, no need.
Need or no need?
No need.
Okay, so very quickly, very quickly. 1 minute. 40%. How to put 40%? Use this formula. 0.4 times 0.5. So it's 0.2 millisecond. So adjust the knob here. And then you have 0.2 milliseconds. Huh? Alright, compute already. Then measure the voltage. Voltmeter reading. Okay. This one, the scope, look at the peak, measure. Then this one, compute. Alright. Then this one, this over VDC. Finish. Then go to the third one. Okay? Okay? Alright, any query? Okay, don't worry. Yeah, I didn't throw in the water and go away.